The total count of electrons would have been 4, atomic number of helium is 2. And then the MOT diagram or the configuration would have looked like sigma 1s2, sigma star 1s2. See, it's going to look like sigma 1s2, sigma star 1s2. Hypothetically, a molecule of this kind would have been diamagnetic because all electrons are paired up. But if you find the bond order, here the bond order is going to be half, 2 in bonding, 2 in anti-bonding, which is going to be 0. Yes, a bond order 0 would mean the strength of the bond is 0. The strength of the bond is 0. Yes or no? And this is the best way. This is the best way to explain the inertness of noble gases. It's the best way to explain the inertness of helium and non-existence of a molecule of this kind. Because a molecule of this kind, the bond order is found to be 0. So again, MO2 happens to be the best way to explain the inertness of noble gases. Fair enough? I hope we can move on. And the problems which are going to be presented to you most of the times the problems in bonding around MOT would be about presenting a species where you will have to find or compare the magnetic nature and bond order. So now let me give you a few examples. Hydrogen H2 plus, nitrogen, then O2 plus, O2, O2 minus, O2 minus minus, fluorine, a possible neon molecule, Ne2. Take your time, you know what you have to do. In all the cases, you have to come up with the total count of electrons. You don't need to draw it every time. You'll just need to, produce it very quickly in the exam hall, and then you'll have to write for the electronic configuration. The question would be, find the magnetic behavior and bond order of these species. Find the magnetic behavior and bond order of these species. Also, now have a go through. Let me know if there is a doubt, and we'll resume shortly.